Hello everyone, welcome to today's video. In this video, we will be talking about first order logic. We will continue with whatever we have left in our last session. So in today's video, we will be talking about free and bound variables, and we'll also look into one complicated example through which we can represent knowledge. Talking about let me give recapitulate what we have done. So talking about this predicate logic or first order logic, it is used to represent knowledge in a more natural form. That means we can incorporate complex sentences or we can combine atomic sentences for representing the knowledge. Now today we will talk about one important concept which is related to the first order logic or the predicate logic, which is known as free and bound variables. So there are two kinds of variables which exists with as a component of the first order logic. So basically these variables are associated with the quantifiers. So the quantifiers interact with the variables which appears in a suitable way, and for that we have, let me write it down first. So we have quantifiers, and these quantifiers would be uh, uh, interacting with different variables within that particular representation. So two different types of variables which we will talk about, or which is used very frequently with first order logic, is first one is free variable. So talking about free variable, a variable is said to be free variable in a formula if a variable occurs outside the scope of the if a variable occurs outside the scope of the quantifier, occurs outside the scope of the quantifier, which means that if I am using a particular variable and that particular variable do not have any quantifier associated with it, but it is just considered as a term inside the predicate, then we can consider that it is a free variable. For example, if I have a representation something like this, so for all x and for some y, we have a predicate which has three different terms, that is x, y and z. Now here, if you are considering the quantifiers for x and some y, so we are associating quantifiers with x and y respectively. Okay, so but here we are not associating any quantifier with z, but it is there in the representation or in the knowledge base. So z is not associated with any of the quantifiers. That means it is not interacting with the quantifier, and hence we can consider this as a free variable. So here we will consider z is a free variable. Now this z we do not need to represent it using any sort of quantifiers. Talking about bound variables, now a variable is said to be a bound variable. So this is the second type of variable. So it is said to be a bound variable in a formula if it occurs within the scope of the quantifier. So occurs within the scope of the quantifier. So this is basically a bound variable. Now here, if I am considering for all x, okay, then we have a predicate which is a of x and b of y. So here x and y, they are both bound variables. Now x, we have already associated one quantifier, and we have also associated that the predicate which is there, b of y. So y, although we have not associated any quantifier with it, but b is within this particular bracket. That means within the scope of x. Alright, so if it is within the scope of x, that means we will be considering this as a bound variable. So talking about this free and bound variable, it will lead us to a different concept, which is knowledge engineering. Okay, so if we are considering first order predicate logic, so we need to concentrate on another important factor which is associated with it, and it is known as knowledge engineering. So knowledge engineering is basically a process of constructing a knowledge base in the first order logic, and it is known as knowledge engineering. So if we are considering a knowledge construction of a knowledge base, this is similar to a database which will be storing all different or every information related to the real world and its associated parameters. So someone who investigates a particular domain and learns important concept of that domain and generates a formal representation of the object, that means basically we are talking about a knowledge engineer. So this knowledge engineer would be incorporating the knowledge inside the knowledge base. Okay, so that knowledge engineer basically would be responsible for doing research and understanding the important concepts of that particular research, and it will generate a formal representation. That means it will generate a formal report or a formal representation which will be stored in the knowledge base. Okay, the approach is basically for any for if we are considering any scenario. Okay, for knowledge engineering process, we have to understand that the knowledge engineering itself is not a very generic term. It is also known as a special purpose knowledge base. So what do we mean by this special purpose knowledge base? So suppose now, let me give you one example. So suppose if we are considering the electronic circuit domain. Okay, if we are considering a circuit, if we are considering the domain which involves electronic circuits, design of electronic circuits, then experimentation on it, the outcome of it, so that is very very specific to electronic circuits. So knowledge engineering also should be a very very specific and a very very domain centered approach, because without it, if we keep it in a generic form, that would not serve the purpose of creating a knowledge base in order to identify the task or identify whatever application we need to incorporate that particular knowledge in. Okay, so it involves several, this knowledge engineering process, it involves several processes. First of all, we have to identify the task. So identify the task. So the first step of the process is to identify the task, and we will include various reasoning based or various reasoning processes in this particular task. The second one is that we also within this identification of the task, we will also assume the functionality as well as the different structure related elements in this particular task. Then the second point is that we will assemble the relevant knowledge. So the second step is assemble the relevant knowledge. And in this step, we will be assembling the relevant knowledge which is required for that particular domain. Like I said, for electronic or digital circuits, we need to understand, initially we need to find out what are the already existing facts related to digital circuits or electronic circuits, and we have to assemble that particular knowledge. Okay, then the third one is that we have to decide on the vocabulary. That means we have to select the functions, the predicates and the constants which we can represent the circuits. Okay, so we will have to decide on the vocabulary. That means we have to find out the appropriate words which can be used as predicates or as constants in order to represent that particular domain. Like for circuits, if we are considering, Then we have to identify words like gate, and, or, nor, zor, circuits, terminals, etc. This will not be applicable to some other domain. So hence we have to decide on the vocabulary. For relationships, we cannot go for words like gate or and, or, zor, not. Okay, we have to go for relationship based vocabulary. So that particular step is important. Now the fourth important step is to encode the general knowledge about that particular domain. Okay, and for that we have to have certain rules. Okay, so encode general knowledge about the domain. So this strictly adheres to the rules. That means what type of rules or inference rules we will be using in order to encode the general knowledge about the domain. We already did inference rules. You can go back to the previous video and check what inference rules are. Okay, the fifth important point is we have to encode a description of the problem instance. So encode the description of the problem instance. Now what do we mean by this is that now if we encode the problem of a particular domain, first we have to categorize the different components of that particular domain, and if we have already categorized it, that means that categorization is easy if ontology about that problem is already understood and thought of. Okay, and this particular process would involve writing simple atomic sentences of the instances of concepts, which is also known as ontology. So we will basically focus on writing atomic sentences so that we have a better understanding of the various problem instances. Okay, so instead of going for complex representation in one go, we have to first break it down into smaller atomic sentences. After this step is done, we have to pose queries to the inference procedure and get answers to it. That means we have to find all possible set of values for all types of scenarios in that particular domain. Okay, and the last and the final step is we have to debug the knowledge base. That means if there is any kind of error, then we definitely have to go ahead and debug the issues of the knowledge base. So after this particular step is done, we can consider that our knowledge base is successfully implemented. So these are the 7 different steps. First of all, we will identify the domain with reasoning processes. Secondly, we will know some facts. If we have some facts, known information about that particular task, we will assemble them. Then we have to find out the correct vocabulary, correct words which will be represented as predicates, as terms, as constants, as functions and variables in that particular knowledge base. Then we have to decide on what type of rules do we need in order to represent this particular knowledge, the different information. Then the fifth important step is we have to build atomic sentences based on the various predicates and various vocabulary we have identified. Then we have to pose queries to the inference procedure and find out whether we are getting the answers or not. And finally, if there is any bug or any error in the knowledge base, we have to debug it. And after that, we can simply consider that the knowledge base is successfully implemented. So these are the things which are associated with knowledge engineering process when we are considering a simple first order predicate logic. And as like in propositional logic, when we are considering the first order predicate logic, these are also represented using rules of inference, where we have modus ponens, universal specialization, resolution, modus tollens, simplification, etc. And here we have one more factor or one more rule of inference which comes from from a non-deductive category, non-deductive rule of inference, rules of inference. And under this we have abduction, induction, and analogy. Induction and analogy. So we will also do this abduction, induction, and analogy in subsequently in the session. So let us first okay, before we go ahead, let us first complete abduction, induction, and analogy. So first of all, let us consider abduction. So when we are considering abduction, now this abduction, induction, and analogy, this is an addition to the already existing rules of inference which we have discussed in our last video. Okay, so talking about this non-deductive rules of inference, first of all we have to understand that these rules are followed to arrive at a conclusion in order to take a decision which is most likely to be valid or correct, though guaranteed to be so. Okay, so abduction, if we are considering first premise, so if we are considering premise 1, so here if we are considering if P is true then Q is true. Now premise 2 would be Q is true, therefore conclusion is P is true. So therefore P is true. Now can we take an example for it? So if I am considering if you work hard then you will be successful. So this is the first one, which is P implies Q. The second one is, let me write it down here. So Q would be you are successful. So what is the conclusion? So conclusion basically saying that therefore you have worked hard. Okay, so this is what abduction is all about. The next one is induction. So in practical life, if we find a statement to be true for a number of cases, we also assume that it is true in general. Okay, so this is expressed by the inductive rule of reference. So if premise number 1, which is saying P of A1, then premise number 2, which is saying P of A2 is true. Okay, then premise number P K. Okay, so this will say that, this will say that this is also true. Then what can we conclude? Conclusion would be that therefore for all x, if for all x we can consider that x is true. Okay, so induction is such a condition that if we find that a statement is true for number of cases, that means it is true for 1, 2, and P of K, and in between as well, so we assume that it is a truth, universal truth. Okay, so suppose if I am considering premise number 1 is, let's say Mr. X is a businessman and he is rich. Okay, premise number 2 is also Mr. Y is a businessman and he is rich. Let's say last one, Mr. K is a businessman and he is rich. In between, let's say premise number 3 also, Mr. Smith is a businessman and he is rich. Premise number 4 also states that Mr. Ansari is a businessman and he is rich. So what should be our conclusion? Our conclusion would be, therefore all businessmen are rich. So this is true. Okay, so we consider it as a universal truth. Okay, now the third important factor or the third important rule of inference is analogy. So when we are considering analogy, if a situation or object or entity is similar to another situation or object or entity in some aspect, then they are likely to be similar in other aspects too. Okay, so if I'm considering premise number 1 as, if P is true then Q is true. Okay, so premise number 2, it says that P is equivalent to P1. Then premise number 3, it states that Q is equivalent to Q1. Okay, so therefore we would conclude that P is equivalent to Q. Okay, so let me give an example through this. So first, if I'm considering premise number 1, okay, so let me consider gentle people are soft spoken. So people are soft spoken. So if we are considering that gorillas are much like people, okay, then let's say, so I'm considering gentle people, okay, or let's say only people as P and soft spoken as Q. So here if I'm considering soft spoken creatures are humble. So here what we will let us conclude that P1. Okay, so therefore we can conclude that gentle gorillas are humble. So if you look into this example, so this will, the gentle part I can remove. Okay, the gentle part, so people I am considering as P and soft spoken as Q. Gorillas is P1. Okay, and we already have P, okay, here, so here it is P and this is Q. Then soft spoken creatures we will consider as Q. Okay, soft spoken Q, and humble as Q1. Okay, so this should also be 1. So here we will consider that gentle gorillas, which is P1, are humble, which is Q1. Okay, so this is how analogy is done. So here if an object or entity is similar to other situation or other object or entity in some aspect, then they are likely to be similar in other aspects too. Okay, so this is how analogy is represented. Now let us look into one more example, one final example in which we will try to represent the predicate logic or represent a particular scenario in a in predicate logic or in first order logic. Okay, so there are certain statements which are given to us. So this is a long example, so we have to focus. So first of all, we have 8 different sentences. Number 1 is Marcus is a man. Okay, Marcus is a man. The second one is Marcus was a Pompeian. The third one is all Pompeians are Romans. The fourth sentence is Caesar was a ruler. The fifth sentence is all Romans were either loyal to Caesar or hated him. And number 6 is everyone is loyal to someone. Number 7 is people only try to assassinate rulers they are not they do not like. Okay, so people try to assassinate rulers that they are not loyal to. Let us write down this sentence. People only try to assassinate rulers they are not loyal to. And number 8 is Marcus tried to assassinate Caesar. Marcus tried to assassinate Caesar. Okay, so these are the 8 sentences which are there, and using this 8 sentence we have to find out whether we get answer to one possible question, which is, was Marcus loyal to Caesar? So was Marcus loyal to Caesar? So talking about this particular question, if we are considering this, let me write it down here. Was Marcus loyal to Caesar? So we have to find out answers to this particular question, that was Marcus loyal to Caesar. So now let us first focus on representing this entire scenario using predicate logic. So when we are using first order logic or predicate logic, first sentence we can represent it something like this. So Marcus is a man, so here my predicate is man and Marcus is the term. Okay, then Marcus was Pompeian, so we will create another predicate, Pompeian, then Marcus. Okay, then all Pompeians are Romans. So here we can write down that for all x, if x is a Pompeian, then x is Roman, right? So this is how we can represent this. The next one is that Caesar was a ruler. So Caesar was a ruler. So ruler here is predicate. Now the next fifth important representation is that all Romans were either loyal to Caesar or hated him. So all Romans, so for all Romans, that means for all x, if x is a Roman, then x would either be loyal to x would be loyal to Caesar, or x would hate Caesar, right? So this we can represent it in this particular way. right? The next one is that everyone is loyal to someone. Okay, now here we have two different terms or two different subjects, which is everyone and someone, and loyal to is the predicate. So for all x, which we are considering as x as everyone, okay, so x, if we are considering y, okay, then x is loyal to y. So this is how we can represent everyone is loyal to someone, or we can write like this also, for all x and some y. Okay, some y, x would be loyal to someone, right? So this is a better understanding, will give you a better understanding of this particular representation. Now people only try to assassinate the rulers that they are not loyal to. So now here we will have to represent this in a particular complicated way. So first let us consider for all x and for all y. Okay, if x is a person, if x is a person, and if y is a ruler, if y is a ruler, then also we have to consider the assassinating, that means try assassinate, try assassinate. Who will try to assassinate whom? X will be trying to assassinate the ruler if x is not loyal to y. Okay, x is not loyal to y. So this is how we can represent this. All right, so this one is 1 2 3 4 5, then we have 6, then we have 7. Okay, so you have to understand the 7 point really carefully. So for all x and all y, if x is a person and y is a ruler, and x will try to assassinate y if x is not loyal to y, right? Simple. So last one is saying that number 8 would say that who will try to assassinate whom? Try assassinate, try assassinate Marcus, will try to assassinate Caesar. Okay, so Marcus will try to assassinate Caesar. So this is the final important representation that we have. Now here we can simply use, if we are considering all the 8 representations here, basically all 8 representations are not needed in order to solve this particular question, that was Marcus loyal to Caesar. So where we are considering loyalty, we can consider this loyalty factor by using only 7. I mean, we can use find out the answer of this particular question using just 7 and 8, where people only try to assassinate rulers that they are not loyal to, and Marcus tried to assassinate Caesar. So if we are considering this particular situation, then we can only use 7 and 8 in order to derive that Marcus is not loyal to Caesar. However, we can also consider point number 1, that Marcus is a man, and point number 4, which is Caesar was a ruler. Okay, so these 4 points we can consider that in order to solve this particular question. Other points, which is whether Marcus is a Pompeian and all Pompeians are Romans, and all Romans are either loyal to Caesar or hated him. So these things, and everyone is loyal to someone, so these things are not basically needed in order to solve this question. We can simply solve this question using either 7 and 8, or we can also combine 1 and 4 along with 7 and 8, because we also need to find out whether Marcus is a general person and Caesar was a ruler or not, right? So this is what, basically this is how we can derive answers using predicate logic. And before we are actually we come to an end of this particular topic, we have to discuss a few points, which is, if we are converting English sentences into logical sentences, they might have certain issues, like they can be ambiguous, and even in very simple situation, a set of sentences is unlikely to contain all the information necessary to reason about the topic in hand. Okay, so if we have to introduce new facts into it, like I already said, using 7 and 8 we can simply conclude that Marcus is loyal to Caesar or not. But whether Marcus is a general person or Marcus is a ruler, we can identify or remove that ambiguity by making use of 1 and 4 necessarily. So hence we have to keep this in mind, that we cannot use ambiguous statements, and we have to find out an alternative to the problem which gets associated due to lack of information in a single representation. So that is all from predicate logic. In the next session we will be discussing more about matching techniques as well as ATNs in detail. Okay, so thank you.